All right, let's look at a famous probability problem called the birthday problem. The problem is, or the question is, given n people, what is the probability that at least two of them have the same birthday? So to solve this, we're going to assume that our confidence about when people are born is distributed equally among 365 days in a year. And I said all of the 365. Since leap years only happen one every 4 years, to make things a little bit easier, let's ignore February 29th in our computations. So let's let A be the event that at least two people share a birthday. Then A complement is the event that all the birthdays are distinct. And probability of A is 1 minus probability of A complement. Probability of A complement is actually a little bit easier to compute directly, so we'll do that and subtract it from 1. The probability of A complement equals the number of repetition-free birthday sequences of length n divided by the total number of birthday sequences of length n. So the top is, I guess we have 365 choices for the first birthday, then 364 for the second birthday if we don't want it to be the same as the first. And then we have a product of 20 numbers here, n numbers here. So the nth one is going to be 365 minus n plus 1. Because we're taking 365 minus 0, minus 1, minus 2. So minus n minus 1 would be the nth one. And then the total number of birthday sequences, every person could have any one of the 365 days as their birthday. So 365 to the n. Now in our class, if we take our class as a group of people, we have 20 students plus 1 grader plus 1 instructor so n equals 22. Now it's a little hard to plug this into a calculator because the numerator alone gets very big, the denominator alone gets very big. I mean, it turns out to be a number between 0 and 1, so it's not a terrible number. But, so I wasn't able to get an exact answer here. But we can see from the book that when n equals 22, that this number is slightly greater than 1/2. When n equals 23, it ends up to be slightly less than 1/2. So, probability of A for our class equals 1 minus probability of A complement. So if our number is slightly greater than 1/2, then 1 minus it is going to be slightly less than 1/2. So I created a survey that I put on CourseSite, and if you guys will all enter your birth month and birth date, ignore the year, you don't have to enter your name, we'll just use those two numbers. Then we'll count up how many people had different birthdays and see if we have any repetitions in the class. So by the size of our class, the probability is very close to 1/2. So it won't be too surprising if we have two people with the same birthday, and it won't be too surprising if we don't have two people with the same birthday. If we had a much larger class, 40 to 60 students, then it would be very likely that we have two people with the same birthday, which maybe is kind of surprising because we think about 60 people and their birthdays distributed out over 360 roughly days, then it doesn't look like we're obviously going to use all of the days. So maybe it looks sort of surprising that it would be so likely for two people's birthdays to fall on the same day. But that's the way it happens. So when you get a chance, fill out that survey, and I will let you know what happens in our class. The end.